So my name is Ghan Vashishtha. I'm the co-founder and CTO at Zeeve. And Zeeve, as of today, is world's #1 Rollup-as-a-Service provider. We have the largest number of DevNets and testnets running through our automated platform. In fact, we have automated the deployments for quick DevNets, ephemeral networks for all major stacks, including Polygon, Zksync, Optimism, Arbitrum, being in the official implementation partner capacity. And then we have a very in-depth monitoring dashboard, analytics around all these rollups, which the customers run and enjoy with full stack approach, having bridges, explorers, all being bundled into it. But yeah, going back to the discussion again, Lois, so you talked about MEV. I'm sure a lot of Web3 users, they know about MEV, and some of them know about it in depth, but most of them they fear it. So can you describe a little about what MEV is for them, and why having encryption and more security or more focus around MEV is important, specifically in the world of rollups nowadays?
Of course, yeah. So let me try two different approaches here. So one is kind of the definitory definition is essentially saying MEV is the maximal extractable value is the amount of value in, let's say, dollar terms that is extracted from essentially meddling with the transaction order. Yeah? So either from front running or injecting transactions or from back running, actually anything that is like meddling with the transaction order and then extracting value from it, that's essentially MEV. And then the simple example is your typical front run, yeah, which also happens in the non-crypto world, the real world, essentially, right? Where you have, let's say, a big order coming in to an AMM or a DEX, even like a normal club order book DEX or order book exchange, where someone has some type of prioritize or kind of someone can see transactions earlier than others, essentially. For example, because they are connected to the block producer in a better way than other people. Maybe they have some back channel or there's some way to communicate with them. So you want to do your big trade coming in, and this other person is seeing it and is able to exploit the knowledge of that trade uh, because obviously that big order is going to change the price significantly potentially, right? So exploiting that knowledge, and then in crypto, it's you can do these atomic transactions, right? So you can then actually slot in a transaction right before, buy at a cheaper price, big buy order drives up the price, and essentially then for the user, it looks like this, that essentially the user is then going to max out their slippage and is going to lose a substantial amount in the trading performance, right? So I think that's essentially gist of it. And the other approach, maybe to explain it, is essentially it's sort of what blockchain is all about, right? So blockchain is essentially Satoshi Nakamoto and the Bitcoin white paper talks about the clock, right? So it talks a lot about transaction ordering and making sure that this blockchain is essentially a clock that a very trustworthy clock that orders transactions, right? And this works extremely well on the 10-minute scale, or on Ethereum on the, say, 10-second scale, right? But it doesn't really work below, let's say, 4 seconds, because globally you have network round trip latency. So at that smaller level, transaction ordering, blockchain actually doesn't really solve what it's designed to solve, which is transaction ordering kind of fairness, right? And that's where the encrypted mempool can jump in and essentially take that role of fixing it.
Right, and it completely makes sense. And specifically, we have also seen a lot of interest in our customers when they come to us, and we deploy these rollups for them, layer 2 solutions where sequencers are there ordering these transactions, and key management is changed drastically. It's not as it was before years ago. It has taken different shapes and names. So it would be lovely to hear from you about distributed key management itself, and what is its relationship with MEV protection or encrypted mempools.
Or if you mind, let me add one more detail on because the question was specifically like why is it beneficial for app chains or L2s, right? So as an L2 app chain, you might be thinking about, okay, users can just trust me not to front run them, right? So it's fine, right? They just trust me. I won't front run them. That's fine, right? But I think that's slightly short-sighted, because sort of just trusting an operator not to front run is not a sustainable kind of outlook for the future. And even sort of from the regulatory side, that trust component will probably at some point come with responsibility, right? So if you are able to front run, and then do it, then it's like this very trustworthy role, which looks a little bit like like a bank or like an exchange in the real world. So regulators actually looking closely at this, and there's lots of statements from regulators in regards to MEV and front running. So I think that's another reason to look at MEV prevention, not just kind of from the practical perspective, but also from a kind of trust perspective, not wanting to have that responsibility, and also from the overarching base layer neutrality and censorship resistance perspective. Yeah. And then your question was about what is distributed key generation. So I think it's a really interesting tool. And specifically, so distributed generation just means multiple parties collaborate to generate a key, right? But threshold encryption specifically is pretty interesting, because it allows this threshold to say any amount of k out of n can collaborate to generate these keys. And then another interesting property of this is that the result will always be the same no matter which k collaborate. And also another aspect of it is this way sort of you eliminate the free option problem or the last look problem. So if you don't have threshold encryption and you just have a distributed key generation mechanism, you will have sort of always a last party to be able to say, no, I don't want to submit the last key share, sort of, right? And then they can block the whole process or kind of extort the others and block the process, right? And they then have the free option, let's say, not to decrypt, which they can then exploit. But the cool thing about threshold encryption is there is never any single last party to do that, to have that step, because you always have a number of players. If you have like I don't know, let's say a 20 out of 50 threshold, you'll always have 30. Then you're, let's say, at 19 out of 20, right? So you have that kind of free option problem there. If you're at 19 signers going up, and then you just need one more, right, to get to the 20. You don't have just one party. It's not just the one leading to the 20, but it's essentially the 50 minus the 19, right? So it's 31 31 nodes. Any of them can do that last step, and it's extremely unlikely that all of these 31 entities are going to be malicious, essentially, right? That's a really cool property, and it can be exploited for all kinds of interesting purposes.
Right, and I think, but just going back to the previous point, I think you rightly mentioned about the trust factor. Web3 is designed to achieve trust. So I think, if today somebody says that, I trust you, that you would not do, exploits on my transactional layer just because you control it. And specifically in rollups, we have seen a lot of customers, they go with centralized sequencers still. And when that happens, the role of, infrastructure provider becomes very, very important. So that's why we partnered with Shutter, because as Zeeve, when we offer these rollups to our customers, we want to ensure that they still can trust the infrastructure layer and control the outcomes in all benefits and ways they would want. So I think, yeah, that was a very, very interesting point. Now, just coming to a specific about rollup or action ecosystem. So we have to offer different integrations to our customers, and Shutter being one of the most prominent ones when it comes to security and MEV protection. But you know in terms of value and differentiator, if you have to talk about how Shutter is way different than and way amazing than those other competitions or other options, if even available out there, then how do you describe it?
Yeah. So I think there isn't a lot of direct competition essentially to Shutter. However, there's generally different sort of approaches how to deal with MEV, right? And usually Shutter is differentiated from this because it tackles the problem one level deeper. So most MEV solutions are kind of just bolted on top and are quick fixing the problem, which is sort of like fine for the short term, but is not actually reducing MEV, but rather just redistributing MEV. And also in some cases, it's problematic because it actually then acts to increase the trust assumption, right, and entrenches some of these centralized, as you mentioned, right, the centralized sequencer. Then if you then utilize a solution which puts even more trust on that centralized intermediary, that's actually not good for the long term. As I said before, it's like that's not how we want to have blockchain to be sort of censorship-less and decentralized. So that's essentially where Shutter differentiates. And then I guess there's some other interesting encrypted mempool solutions which use hardware type of encryption, which is an interesting approach. However, there we would argue that it's actually more powerful to use this type of decentralized threshold encryption approach, rather trust the sort of the decentralization and the threshold encryption, rather than having to trust the hardware kind of trusted execution environment, let's say Intel SGX, right? We've seen a bunch of issues with Intel SGX, but I don't want to fully dismiss it as something that we are even looking into combining into kind of like call it fortified Shutter, so that you would have the Shutter keepers running inside SGX enclaves. So that's an interesting way to combine these, and then you would have to break both the threshold encryption trust assumptions and the SGX enclave.
I think fantastic point. I also heard a lot about trusted execution environment based solutions, specifically built around Intel SGX. But your point is very valid that do not trust encryption alone. Why cryptography alone should be responsible for security. Decentralization can actually add double value or benefit to it. So yes, if you're going that path, we would love to see those outcomes when Shutter would have both capabilities or characteristics coming out and shining brightly. Now, just going back a little, because you said you're not using hardware encryption yet. So it'll be great to know, what kind of encryption it is. And, we have seen in Web3 industry a lot that when people talk about encryption, they also start talking about latencies in transaction ecosystem, some overheads. So how do you tackle those?
Yeah. So just to recap, yeah, we're primarily not using hardware-based encryption, right? We're using that threshold encryption approach, which again we think is a really cool approach. It's basically a simple form of MPC, multi-party computation, but it's very proven and very sort of established. So it's based on identity-based encryption, and essentially it's simpler than very advanced forms of MPC or zero knowledge proofs, which is a good thing because we want it to work right, and we want it and it needs to be efficient. But yeah, we're always looking to extend it and to potentially combine with the hardware encryption with the SGX stuff, or even move into these very interesting fields of more advanced MPC or FHE. So fully homomorphic encryption would essentially at some point allow transactions to remain encrypted, right? Shutter is the commit reveal scheme essentially, so encrypts and then decrypts. With FHE, it could enable us to not having to decrypt, right, and just keep it fully private and still do transaction ordering steps or things like this on top. Very, very exciting, but in our view, not today practical, but super exciting stuff that we're looking into. And then you touched on the question of latency. So that is one sort of the downsides of having an encrypted mempool, I would say, is that slight added latency essentially, which we think is actually necessary. There's a good article from Phil Diane from Flashbots about geographical decentralization and how it relates to latency. So if you try to really go beyond, if you try to have something that's ultra fast latency, at some point you are sacrificing geographical decentralization, right? Because you're cutting off people. Let's say if your sequencer is running in the US, but you'll have participants in Asia, just the network round trip latency at some point then makes it so that certain actors are prioritized versus others. So you're sacrificing geographical decentralization if you go below a certain latency. So we think actually the latency is actually necessary for geographic decentralization, and we're doing everything to keep it as efficient as possible. I think we're currently around sort of 5 seconds of latency of this decryption step, and that only affects execution latency. So inclusion latency is not affected. So you still can get the instant inclusion transaction receipt as a user from the sequencer. And then 5 seconds later, you'll get the actual result of the transaction. So we think it's actually not a big deal. It's something that I actually talk about quite a lot as a trade-off. But we think in practice is not a big deal. And again, looking at the bigger picture, we shouldn't even go below 4 seconds essentially of latency, because then you really start to sacrifice geographical decentralization.
Right. No, I think the way you say it, bigger picture, that matters the most. So my next question is this is about, how does this integration takes place? Because, for example, when we are delivering a rollup, say Zksync hyperchain or an OP stack based rollup to a customer, now does it require some integrations or some enhancements to the core images or the binaries themselves, or it can be done in an abstracted way?
We have several integration paths. That the most applicable to I think kind of L2s and Zeeve, right, as a Rollup-as-a-Service provider, is our Optimism integration. So there we have this the Optimism OP stack testnet live. So in this case, it is a protocol level change. So we have our own essentially OP Geth version that is kind of otherwise unchanged from OP stack, from usually OP stack rollup, but has the integration of the encrypted mempool, and it still allows for unencrypted transactions if you want to send them through. Yeah, but essentially, so for a client, for someone who runs the rollup, it would just entail essentially switching out the client for the client that we built. Yeah, so and then in general, the rollup is then able to process encrypted transactions. And then there's another question about sort of like how do apps actually benefit from it. And there's two options there. One is we have a Shutter SDK, which DEXs can implement into their front end so that the encryption actually happens by the user. So really like end-to-end encryption, right, by the user. And then how we build it for Gnosis chain is sort of one a little bit of an intermediary step where we have the RPC do the encryption step. That's nicer because then you don't have to do the front end changes from the DEXs. But you have that sort of a little bit of trust assumption from the RPC. Yeah.
Yeah, no, that's super. I think you talked about you support OP stack full blown right now, and would love to know what other stacks are there which you support, and what is on your roadmap. What kind of stacks and upgrades and improvements you're eyeing going forward.
Yeah. So currently we're pretty focused on where we have the most mature code base is in OP stack and then the Gnosis chain. So that's basically another beacon chain. So if someone wants to deploy their own L1, and then something that we're pretty kind of set on as a next step is I would say is sort of the Arbitrum ecosystem, and there we're also in talks with Espresso and have some ideas on how to combine Shutter with Espresso, and the learnings from this could also apply to either other shared sequencer frameworks like Espresso, or decentralized sequencer frameworks like Espresso, or also other rollup stacks, let's say like ZK rollups or others. Yeah.
Yeah, makes super sense. I think world would need more of Shutter as much as possible as these rollups starts. Yeah, go on. Sorry.
One thing to add is really like it really depends also on the clients, right? So I think we have a bunch of interest in the OP stack ecosystem from, for example, Mode, and some other OPs like Rollups that we're talking to. We also have preliminary interest in the Arbitrum ecosystem. But if there's a strong rollup with a lot of usage that is interested in utilizing Shutter, then we can prioritize that stack, and we can switch as well. So it depends on the client, and are they interested in this? Then we can prioritize other stacks.
No, I think you made a very strong point. Rollup is a rollup, regardless of which framework it is built upon. It requires MEV protection because it's a key differentiator in terms of how a rollup would grow, secure itself, make a mark for itself in terms of reliability, quality, and what app chain functionality it delivers in the end. So I think this partnership with Zeeve, from our point, it makes a lot of sense because being partnered with Shutter allows us to bring this unique differentiator to our rollup customers who are deploying these rollups. Of course, it's on demand. They can pick and choose, and we can always integrate Shutter and offer them this capability. But from your perspective, do you also see the same picture
of rollup differentiation via Rollup-as-a-Service providers, or?
Yeah, so there's this partnership with Zeeve. Do you see that this is one of the effective ways of channeling this key differentiator into the rollup ecosystem?
Definitely, yeah. So I think as you said, so essentially, I think the whole allure of having different rollups and having a rollup as a service, I think, is to allow as much experimentation and as much interesting different kind of permutations of rollups, right? And we have this beautiful modular stack with, let's say, you can switch out the data availability layer, you can switch out your execution maybe, and you can switch out other things, right? And the encrypted mempool is another really important piece that is actually like a protocol level differentiator, where you can say, as a rollup, not only do we have, let's say, eigenDA as a differentiator compared to another rollup, but we also have this type of encrypted mempool to actually truly sort of differentiate from because now there's really a lot of rollups. So I think new rollups really need to think about how can they be different, right? Because to be honest, the strong big rollups, they're quite dominant, and there's a kind of a network effect, right? So I think if you are a new rollup or if you're a smaller rollup, I think it really makes sense to think about how to reasonably differentiate and add features.
And no, point well made. I think we'll pass this message to all our rollup customers, all the newer ones. We'll try to educate them about MEV encryption, why it is more valuable than ever in this space. And it was lovely talking to you, Luis. And I think we'll have so many more conversations in future, and a lot many joint customers to serve with and take this unique differentiator to their rollup solutions in future. Yeah, thank you for your time, and we'll speak soon again.
Likewise, thank you very much. I really enjoyed this talk, and yeah, looking forward to continuing to collaborate in more such talks. Thank you so much.
Yeah.
Bye.
Thank you. Bye bye.